In the second section of chapter 4, we will talk about the addition rule and the multiplication rule of probability. So first, we will talk about how to use the addition rule. Then we will talk about the multiplication rule. Okay. So first, let's see. If we are talking about the addition rule, we can treat it like probability A happens or B happens, or they both happen. A happens or B happens, or they both happen. Here, we treat or as our keyword. So if you see or, then you will have an idea. I will use the addition rule for this kind of situation, okay? Of course, in some book, you will just use union. A union B, that's the same meaning as A or B. We should use the addition rule. For the multiplication rule, we check. It means event A and event B happens. So they both happen. They both happen. Both A and B happen. So here the keywords is and. Or some book you use this intersect. A intersect B. That's the same meaning as and. So here we will use multiplication rule. Before we talk about multiplication and addition, we talk about compound event. Remember, in last section we talked about what's the simple event. So if simple event means the event cannot be further broken down, then compound event will be the opposite. It's not a simple event. Combine two or more simple events. So that's called a compound event. So let's check what's addition rule, A or B, which means in single trial, A happens or B happens, or they both happen. So that's the definition. Then we will say P, A or B is equal to the sum divided by the total number of outcomes in the sample space. But the most important part is outcome should be counted only once. Outcomes should be only counted one time. Let's check. What does this mean? So let's check the formal addition rule. It is just probability of A plus probability of B. So we call it addition rule. But make sure you should minus the second part, which called probability A and B. So this part, just the double counting part. A and B is just the double counting part. So both A and B here, both A and B is just the A and B both happens at the same time as an outcome in a trial. Let's check this example. If a subject is randomly selected from the wait a second. So we have two rules to get the addition rule. The first one we call it intuitive addition rule. So in this rule, we can use the sum of event A happens and the event B happens divided by the total number of outcomes, right? So for this one, we'll just say, but make sure every outcome is just counted one time. And if the second way, we just use the formal addition rule, use the formula. Let's check this example. We can use two rules to get the answer. So first, let's check the background. So it's about a drug test. So positive test result. We have this column for all the positive test result and another column for the negative test result. And true positive is 45. True positive means positive result and actually uses drugs. So it's 45. For example, it's true negative means negative result and they actually do not use drugs. So this time we will want to find the probability. Select a subject had a positive result or uses drugs. So what should we do for this kind of problem? We have two rules, right? First, let's check intuitive rule. Intuitive rule. If we use the first method, that will be A or B. We will get the sum of A happened and B happened, right? The sum of event A and event B. But make sure do not double counting. Let's check. Event A is here. We treat it like positive result. And the event B is uses drugs. So let's check how many people got a positive result. Positive result will be the first column. We will get this column, 45 and 25. So they have 45 plus 25. 70 people got positive result, right? And plus event B uses drugs. So we check the first row here. How many ones uses drugs? We will get 45 and 5. They both uses drugs. So 45 plus 5 people uses drugs. But here you will be extreme careful. We have double counted 45. So this time you should only put if we can get the sum, right? Then we realize 45 has been double counted. We should make sure this one is just be used one time. So we delete 45. Just leave 145 and divide it by the total number of subjects. So from here we know the total number is 555. So that's how we get probability. Okay, so you can use the calculator to get the answer. Right? It just 75 divided by 555. You can just get this answer 0.135. This is the probability of positive test or uses drugs, and we use the intuitive rule to do the calculation. Of course, we can use the formal rule, right? This time we want to use the formal rule, and you will find they're very similar. Some steps just very similar. If we use this, we will use probability A plus probability B minus A and B. So for this one, how can we get the probability of A? A here is positive result. The probability of A is, we just check the first column. It will be 45 plus 25. That's how many people get a positive result divided by the total people, right? Plus how many people uses drugs. So we check the first row, 45 plus 5, divided the total number we have. But we should minus both got a positive result and uses drugs, which means the true positive. So it's the 45 people got positive result and uses drugs. That's true positive. So 45 people divided by the total number. So if you combine them, finally you will get the same answer. It's just 45 plus 25 plus 5. So we will get the same answer like the previous method. Okay? So it's just the same answer, but I prefer the intuitive rule. I prefer the first method because it's easy to understand. But the most important part is make sure no double counting. Let's check the definition. Disjoint. A and B are disjoint if they cannot happen at the same time. So which means the disjoint events do not overlap. A happen, then B is impossible to happen. B happens, then A is impossible to happen. They cannot happen at the same time. Then they are disjoint. Let's see. If event A, if I select someone who is a male. Event B, I select someone who is a female. So the person cannot be both a female or a male, generally. So we will say they are disjoint. They are disjoint. Event A, select a female. Event B, the subject is a male. These two events are disjoint. They cannot happen at the same time because the subject cannot be both female and male. But when we check these two events, we pick a subject who is taking a statistics course. And the event B is she is a female. So it's possible to get a female statistics class student, right? It is possible to it's possible event A and the event B happen at the same time. So event A and event B, they are not disjoint. So this is just the key points of addition rule. First, we should find the keywords, all. Then, when we use the intuitive rule without double counting, again, first we should find the keywords all. Then make sure there's no double counting when we use the intuitive rule. So that's some property of complementary events. We will say A or A bar. A or A bar. A happens or A not happens. So A and A bar, they are disjoint because they cannot happen at the same time, right? So we can use the addition rule. We only have 2 terms of addition rule because the last term A and A bar will be 0. So we can get this conclusion. PA plus PA bar equals 1. If they are just some transformation of the formula. If we know A bar, we can use 1 minus, if we know PA, we can use 1 minus PA to get PA bar. Same thing, if we know the PA bar, we can use 1 minus PA bar to get PA. Let's check the sleepwalking example. So this time we want to find the probability not sleepwalked. But from the background, we already have one probability. Sleepwalked, the probability of sleepwalked. And we find not sleepwalked is the complementary event of sleepwalked. So which means we know the probability of A, sleepwalked, equals 0.29. And we want to know the complement of A, PA bar. So by the formula, we know 1 minus this PA, we will get PA bar. So that's how we get the probability of PA bar, 1 minus PA, right?